Hello everyone, here is another question by Martin Tutorials. I just made up this question and decided to put it here, but I'm sure this question has appeared in other places. Given a circle with radius 10 meters, find the dimensions of the largest triangle that fits in the circle with at least two equal sides. So we have a circle. We have a triangle with at least two equal sides. The radius of the circle is 10 meters. That means the center to anywhere on the edge is 10 meters. We want to maximize the area of the triangle given these restrictions. A quick reminder, I have two YouTubes, Variety and Fun Math. That's anything unrelated to math and easier math. And Martin Tutorials, which is only mathematics. As today's lesson is arguably more difficult, it will only be uploaded to Martin Tutorials. Now onto this question. We want to maximize area. Okay. Now the formula for area is half times base times height of a triangle. So I've just drawn a diagram. I've added onto the diagram. I let the height equal h because we don't know what it is yet. We know the radius is 10. Which means this little bit here is h minus 10, because that's h, subtract 10 is h minus 10. The reason why I'm doing that, our equation, which is base times height, I want to link b and h. I made the right decision. If it's going to be a calculus question, whatever needs to be maximized or minimized must be the subject of this equation. And what I can see here, we have a right triangle, and that means with Pythagoras we can make an equation that links h and x. Now what I did is that half times base times height, we can see that x is half the base. So instead of half b, I replaced half b with x. So area equals x times h. That x replaced the half b. So area equals x times h, and now we need an equation that relates x and h because we've got too many variables. The good news is what we want to maximize is before the equal sign, but we still have too many variables. And we found a relationship. That's Pythagoras. H minus 10 squared plus x squared equals 10 squared. That's Pythagoras. Okay. So there's the h minus 10 squared. There's the x squared equals 10 squared. I can isolate either the h or the x. I'm choosing the x because it's much easier. So the h minus 10 squared I bring to the other side. That 10 squared becomes 100. X squared equals 100. And the amount you want to do in each step, it's whatever you're comfortable with. I first multiplied out that bracket, that's h squared minus 10h minus 10h is minus 20h, minus 10 squared is 100. That's if you have h minus 10 times h minus 10. When you undo the bracket, the signs change. H squared becomes minus h squared, minus 20h becomes plus 20h, plus 100 becomes minus 100. Those hundreds cancel out. X squared equals 20h minus h squared. That's what we're left with if we remove 100 minus 100. If x squared is this equation, x is the root of that equation. And I rewrote it as 20h minus h squared to the half, which is the same as saying root sign, because when I'm going to do calculus and derivatives, it's easier to use the half. So if I take that original equation, area equals x times h. There's the h, the x, which equals this equation, 20h minus h squared all to the power of half. I substituted in for the x. This x got replaced with this equation because we just said that's what x equals. So now we have an equation with area, or a for area is the subject, and only one variable on the other side. That means derivative time. So for simplicity's sake, I'll call this left and I'll call that part of the equation right. Left derivative times right. The derivative of h is just 1. Right, I don't change it, plus right derivative. I use chain rule. Half times that bracket to the minus a half times the derivative of that bracket, that's 20 minus 2h, and that's the right derivative multiplied by the left. The left is h. And I like to put this underneath so I can see where everything is. That's left derivative times right plus right derivative times left. That left there is h. And now what I do is I simplify. I look at, there's a half there, and we have this bracket to the minus a half. So I take out half, and this 2h minus h squared to the minus half. I take it out as a common factor. If we had a 1 and we took out a half, I put a 2, because 2 times a half is 1. And now I have this bracket to the 1. 1 minus a half is a half. And on the right side, the half times 20h minus h squared to the minus a half gets completely removed. It just becomes a number 1. And we're left with, I could write in 1 in a bracket, times 20 minus 2h times h. And you know what it means if you see a little piece of paper like this? It means I made a horrible mistake. I'm too lazy to rewrite everything, so I put a piece of paper to cover that mistake. So it's not that I want to cover the mistake. I don't want to confuse people if there's something incorrect. Anyway, next step is just simplifying. I rewrite the left, half times 2h minus h squared to the minus a half. 2 times 20h is 40h minus 2h squared plus 20h minus 2h squared. And what I do is the 40h plus 20h is 60h, minus 2h squared becomes minus 4h squared. A half is the same as saying 2 at the bottom, and the power of minus a half means the power of a half as a denominator. And what I do now, I can take out a common factor of 4h. We're left with 15 minus h. And remember, the whole purpose of doing a derivative is to set it equal to 0, because we want to find out what value of 0 is the derivative, makes the derivative 0, to see when it's maximized or minimized. Well, one example is if h is 0. Now, if h is 0, a is also 0. What it is, that's a value of a and h which fits in this equation, but it's not based on a three-dimensional shape. It just fits in the equation. The other answer clearly is if h equals 15. So we've already just solved for h. And once we have h, and we can now solve for x, because we said higher up earlier on, there's an equation that relates x and h, which we had earlier up. So I can take that h equals 15 and plug it in. Over here, there we go. X equals 20h minus h squared to the half. 20 times 15 minus 15 squared to the half equals 75 to the half. And root 75 is the root of 25 times 3 equals 5 root 3. So the height is 15, and x, that big height there is 15, and x, we just said, is 5 root 3. And what I'm going to do is, now I'm going to, I just happen to choose a letter t as the length of this side. And what I can do is, I can use Pythagoras. H is 15. X, we just said, is 5 root 3. I can use this Pythagoras to solve for t. And so, there we go. Root 75 squared plus 15 squared. We said x is root 75, that's 15, equals t squared. Root 75 squared is 75, plus 2 to 5, equals 300 is t squared. So t equals root 300, which is like saying 3 times 100. And the root of 100 is 10, equals 10 root 3. So t is 10 root 3. And what do we know? We know from before x is 5 root 3. The base is 2 lots of 5 root 3, which is 10 root 3. So the base equals t, and that's also t because we said those two are the same, which means the base is the same as t, which means all three sides are the same. The base is 5 root 3 plus 5 root 3, which equals 10 root 3, and therefore we have an equilateral triangle because all three sides are 10 root 3. I hope you enjoyed this question.